Hello, today we are going to first look at your FIM. So you just completed this, and you're now going to uh, copy what I've done in this video. So again, these are the two problems from your PMT last week. With this first one, Power Standard 7, solving a linear equation, this was the graph that we struggled with the most. X equals 2. And the common misconception here is that X equals 2 is a horizontal line because the x-axis is a horizontal line. But what you need to realize is that the x-axis is counting vertical lines, and what x equals 2 means is that the x value for any ordered pair is 2, which actually puts us right here. Oh, not terrible. Okay, and there we go. Okay, y equals 2 has a y-intercept of 0, so this is really plus 0, which starts us here. And then it has a slope of 2, so that's a rise of 2 and a run of 1. And then a rise of 2 and a run of 1. And we connect those dots, and there we go. So that's the point they intersect, and that point is 2, 4. Okay? And again, we had to do this graphically in this one. Some of you did it algebraically, which I was happy with, but they were looking for the graph. Okay? Now, let's see. Over here. So we're going to graph these and say how many solutions it has. All right, so we're essentially going to graph these the same way we graphed these two lines. And I'm going to start with the 2/3 x plus 6. So we're going to start with this, the plus 6, and that's the y-intercept, so we're going to put a dot there. And this has a positive slope, so I'm thinking this direction, and that's a rise of 2 and a run of 3. 1, 2, 3. And hopefully you noticed right away that they had the same slope, which means they're parallel, and a different y-intercept. So this kind of goes back to what we learned earlier this week, and then a lot on these PMTs, is that the x values, the x terms, are exactly the same thing, same coefficient, same sign. They're both positive 2/3, and a different constant. And graphically, that just means a different y-intercept, but a same slope. So these things never intersect. They're parallel. Sorry, it doesn't look parallel, but they are. They're parallel, so they never intersect, so there's no solution. It really does follow the same rule that we learned on yesterday's FIM. Same variable term, different constant. This is how it looks graphically. They're parallel. They do not intersect. This has no solution. All right. Now, that's your PMT, or that's your FIM, so we have that done. So let's get into today's lesson. Write this down at the top of your paper. Relations, chapter 1-6, pages 40 to 46. So anytime you got to write something down and you feel like this video is going too fast, just hit the space bar to pause and you can get caught up. So this is at the top of your paper. Now, the first thing, objective 1, we want to be able to take any of these forms, and this all says the same thing. So we're used to seeing, probably this more often, the ordered pairs matching with the graphing, but all of these say the same thing. So what your job today in this first objective, and this is what you're going to summarize, is that you need to be able to take an ordered pair or multiple ordered pairs, put them into a table, which I sometimes just call a T-chart, put them into a graph, and put them into a mapping diagram. Okay, so that's our goal today. All right, so one more time, these are relations. These are all just the same representation, and that's what we're going to do in the next slide. So, representations of relations, we have these 1, 2, 3, 4 ordered pairs. We want to make them a table, a graph, and a map. So to do that, all we have to do is, I'll write in black this time, we're going to make our T-chart. That's our table of values. We have the X column and the Y column. And I'm going to write the X values. Me personally, I like to write them in ascending order so they get larger as we go. You don't have to do this. You can just write them as you see them, but I'm going to. So -2 is the smallest X value, and its Y value is -1. And then looks like 0. And its corresponding y value is -4. And then looks like we have 2, -4. And we have 4, 3. All right, and then we're going to graph these, and your graph can be doesn't have to be on graph paper. You're just plotting points, so I'll stick with black for the graph. And again, I got -2 on the x. I got 4 on the x. 1, 2, 3, 4. And then 3 is my highest y value. 1, 2, 3. And -4. So that'll get me through it. And I'm going to use a different color for my points. So -2, -1 is right there. 0, -4 is right there. 2, -4 is right there. And 4, 3 is right there. So I've now made a graph. And then a map is essentially this thing. We just don't repeat any x values, but there aren't any repeaters here. And we try not to write any repeat y values. So we start with, that'd be something you probably want to make a note of. You probably know how to do these two things. But in the map, we don't write any of the repeats. We just draw, multiple arrows. So I'll show what I mean by that. So you start with I like to just do squares. You can do whatever you want. Oval or circle or whatever, it doesn't matter. And I'm going to write down the x values. -2, 0, 2, and 4. And then here I have 3 different y values. I have -1, I have -4, twice. I'm only going to write it once though, and I have 3. And then I'm going to take my pen, I'm going to change it to red again, and I'm just going to map these onto each other. So -2 goes to -1. It's an awesome straight line. 0 goes to -4. 2 also goes to -4. And you're going to see in the next chapter how this can be, not this situation, this one's okay, but we can have issues when one element from the domain goes to 2 different range values. That's not a function, but that's actually covered in the next section. And then 4 goes to 3. So this one is a map. So we've checked off all 3 boxes. So again, you're probably going to be familiar with these. Here, domain values or x values. So these are the domain or x. You're more familiar with x. And this is the range value. Range value are the y values. And you just draw arrows and how they're linked together. All right. On the next one, actually, I'll have you do that later. So what I want you to talk about now are independent and dependent variables. That's just another name for domain and range and x and y values. Your job is going to be to pick these out of a story problem. Okay, so an independent variable is just a variable that determines the output. It's essentially the x value. You plug it into the equation. All right, it determines the dependent variable. So the dependent variable is dependent on what the independent variable is. All right, and then the output is the y value. So the dependent variable is the output. It's the y value of, if you were thinking kind of like in terms of an equation, it would be the y value. And your job is to identify the independent variables and the dependent variables. All right, so here's our first story. In warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. What is the independent and dependent variable? So what you got to think of is what is affecting the other. As in this case, the independent variable is actually the daily temperature. So as we see the daily temperature rise, we know that the amount of electricity is also rising, right? And then as the daily temperature falls, we know that the average electricity use is falling as well. So the outside temperature is causing the electricity use to rise or fall. So the independent variable is the temperature, and the dependent variable is the electricity usage. Okay, so the amount of electricity we use depends on the temperature outside. So this is probably obviously something to do with air conditioning or something like that. Now, in our other problem, the number of calories you burn increases as the number of minutes that you walk increases. So again, this depends on how far you're walking. So our input is the number of minutes you're walking. Our output is the calories you burn. So the independent variable is the time you're walking, and time is almost always an independent variable. If you're ever stuck on a problem that includes time, it's usually the independent variable. And then the dependent variable is calories burned. So what you're going to do in your homework is you're going to look at these problems here, and you're going to determine what the independent and dependent variable are. All right, so that's all we have for you to work on today. The homework assignment is, oh, I got one more. I forgot about this one. Analyzing a graph. So the graph represents the temperature in Mrs. Ling's classroom. So this is kind of again, an independent and dependent variable type problem. Describe what is happening in the graph. So in this graph, right, we have something in a classroom, and we notice that temperature, as time increases, temperature is rising. All right, and if you're familiar with a thermostat, this is exactly how the thermostat works. This probably in the morning, and the temperature is set low, right? Because at night we don't need the temperature to be as hot, nobody's here. But as students arrive, we might want the temperature in the classroom to rise because it's, you know, it's probably winter out, and it is winter out, and it's cold, so we want to keep you guys warm. So let's say maybe the temperature here, let's say at nighttime we have it set to 60 degrees. All right, but then when students come in, we want it to be maybe 68. Okay, I'm just making something up. I have no idea. It doesn't really matter in the story. So, boom, it's time the students get here, and the heater kicks on. So the temperature rises to the desired temperature, which is 68 degrees. And then what happens is the thermostat tells the heater to shut off. And so it shuts off, and the temperature drops a little bit. And the thermostat has kind of like a threshold. It's probably a couple degrees. And when it hits this threshold, let's pretend it's 66 degrees, it kicks on again and gets the temperature back up to 68. It shuts off, and the temperature drops slightly, and it just happens throughout the school day. All right, and then what happens here is this is probably the time for you guys to go home, and the thermostat says, okay, it can be 60 degrees again, and that's what happens. And then what probably happens again is we get this little jump up and down again, and then you guys come back the next day and it comes up, and then we have it cycle through its on and off phase. All right, so you're going to describe stories like this from a graph. All right, and here's exactly what I just said in there. Okay, and now your homework tonight is to work on these problems. Okay, so work on those, and I will see you guys next time.